All right, so we're going to go ahead and get started here. First of all, I'll just say apologies up front for background noise. Got hot water heater being installed in my house at this moment, and my dog's going to be going crazy barking. So I have the door closed, so hopefully that'll be all right. So we'll go ahead and continue here. So we're gonna find this is the last problem we left off at. We did one of these problems yesterday with the graphing, and so we'll go ahead and continue this. So this is a review from last time. Right here, if you want to find the x-intercept, you want to set the top equal to 0. And so just have to make sure I'm on the comment mode here. So put that on. Okay, so now if we're going to set the top equal to 0, it's going to be 2x. So actually, first, let's go ahead and factor this one before we jump into finding this information. So if we factor it first, right here, we're going to, you can get a common factor on top. 2x comes out. That's going to leave us with a x plus 2. And the bottom, we can factor this one as well. Factors of 15 that add up to 2 will be a 3 and a 5, with a positive 5 and a negative 3. Nothing cancels there, so we can kind of move on and answer these. So we're going to set the top equal to 0, so 2x times x plus 2, set that equal to 0. And so we'll get 2x is equal to 0 and x plus 2 is equal to 0. And we get x is 0 and x equals negative 2. And those would be your two x-intercepts. In fact, let's go ahead and we'll put those down right away here. So 0 and negative 2. For the y-intercept, you want to put a 0 in for x. And so we can put that in the original one. But what's going to happen is everything's just going to turn into a 0. So we got that. We have 0 squared plus 2 times 0 minus 15. So we get a 0 over negative 15, and that's going to be a 0. We already have it. 0, 0 is our x-intercept and y-intercept at the same time. So it's going to be both of those. All right, so next we're going to find the vertical asymptote by setting the bottom equal to 0. We already factored that, so x minus 3. X plus 5 is going to be equal to 0. And if we solve for that, we're going to get x equals 3 and x is equal to negative 5. So that's going to look like some dotted lines here. So we have a 3 here and we have a minus 5. Those right there. So we have that. Okay. Now we want to do the horizontal asymptote. Now, yesterday we talked about the rules. We go back to this original one, we see that the highest power on top is the same as the highest power on the bottom. And so when that rule happens, when we have that, this is going to be, yesterday we talked about, this is rule number 2, where n equals m. And when that happens, you have this formula, a of n over b of m. Okay, so we have that. And so if we look back at the coefficients that are there, that's going to be, there's a 2 on top and there's a 2 on the bottom. So that's why the powers are the same. We're using rule number 2. But now we want to look at the leading coefficients in front. There's a 2 on top and a 1 on the bottom. So the a of n is 2 and the b of m is 1. So we'll go ahead and put those in here, 2 over 1. So y is equal to 2 is the horizontal asymptote. So because it is 2, we will put that in right here. Okay. Now the problem that we did the end of class yesterday, this one here, we had to use some test points to determine whether this part was in this section or if it was above. We did the same thing on the end over there. However, this graph, we don't have to actually do that. Now, the reason why we don't have to do that is because, for instance, let's suppose that it was drawn like this. Well, if it was drawn like this, notice that the graph would have to cross the x-axis here. And if I look back at the x-intercepts, we only got two x-intercepts at 0 and -2. So it couldn't possibly be drawn this way because in that case, if it was, you'd be crossing the x-axis. Same idea over here. If I drew this, coming up like that, for instance, that would be crossing the x-axis there. And that's not possible because we didn't solve for that algebraically. So I don't even need to use a test point. I already know for sure that the graph is going to be up here, and it's also going to be over here in that section. So I already know that without even doing test points, I already know for sure the graph is going to be up here for both of those. Now, certainly we could use a test point if we're unsure. We could put in a test point. I would put in like -6 here and maybe a 4 on this side, and we would end up getting values that are up here in these sections. But you don't have to worry about that here. And again, these kind of graphs, you're doing a multiple choice anyway on these. So you'll just choose the one that has these up here. Now we have to figure out what goes on in the middle. At the end of class yesterday, I told you that if you're between two vertical asymptotes, you have one of these four shapes that's going to occur. So we've got these. So it's either a U shape, an upside down U shape, or that you have ones that look like cubes. So between the two vertical asymptotes, we have one of these four shapes. So here we have two points that are there. So that tells me that the graph is either going to be a U shape, it's going to come down, or it'll come up from the bottom. So I only have to actually use one test point here. I'm just going to test a point in between these two verticals to see whether the graph comes from up above or up from down below. Now, it doesn't matter which one of these points that you test, but I'm going to test -1. So I'm going to test x equals -1. And you're going to put that into you can either use the original equation, or if you want to use the factored version, it doesn't matter which one of those you want to use. Okay, so it doesn't make a difference. So what I'll do is I'll do put it into the original one that we have. So I have 2 times -1 squared plus 4 times -1. And then I'm going to put that on the bottom. On the bottom, we have a 1x squared, so -1 squared plus 2 times -1. And then I have -15. Okay, so putting this all in here, this is going to give us an actual point on the line itself. So up here, I'm going to get 2 minus 4. So that's -2 we get on top there, because this is positive. So 2 minus 4. On the bottom, okay, if I do that, I get 1 minus 2. Okay, so +1, and then -2 is -1 minus, so I get -16 here, which is the same thing as +1/8, which means that the point -1 and 1/8 is on the graph. So I'm going to put that's going to be right about here. So because we get that kind of curving shape, that's going to tell us now the graph is going to follow this vertical. It's going to come up from the bottom. It's going to go through these 3 points. And it's going to go back down and follow the other vertical asymptote. And so that's what the graph is going to look like. So we have that. If it did ask you for, we'll do a domain on this one. Okay, so let's do domain, even though it doesn't ask for it originally, but it may ask you that in the homework. So let's do that for here. If we look at the graph, we've got 2 vertical asymptotes, and that's where we're dividing by 0. Or you can just look at the factored version we had back here. So 3 and -5 causes you to divide by 0. So if you want to find the domain, it's going to include everything except for 3 and -5. So you want to go -infinity. We do have to put the smaller number first when you're doing that one. So -infinity, -5. And then from 3, I'm sorry, the middle one we need to put here. Okay, so we're going to go -infinity, -5. And then we're going to go from -5 to 3. There we go. Now it's correct. And then from 3 to infinity. and that would be your domain. So basically, again, it's including everything except for 3 and -5. Okay, so that's what the domain would be if it asks for. Won't ask you for the range on this kind of question. Again, because we have to know exactly how high this point goes up to. It's 1/8. So there's no y values being used between that. But again, this section, they're not going to ask you that for the homework questions. I'll just do a quick double check here just to make sure. But they don't usually ask you for that. The previous section before has a couple questions on range, but again, that's mostly off of a graph instead. And so these here, I'll just double check this to make sure. And yeah, they're not going to ask you for that on this one. They are going to ask, however, let's go ahead and do this for this particular problem. It asks you for what part of the graph is above and below the x-axis. So we're going to do that on this question here. So f of x, let's do that here again. So I just want to make sure I'm doing exactly what the homework is asking you to do. F of x, we'll say f of x above x-axis, f of x below x-axis. So this is x-axis, this is x-axis. Okay, so above x-axis and below the x-axis. Let's do that for this one here. All right, so let's do above the x-axis. So we have this section. So we have negative infinity to -5. Okay, so negative infinity to -5. It's above. We have this little small section right here between -2 and 0. The graph is above. So I have to include that as well. So between -2 and 0. And then we have this last section that's above. And that's this piece, which is going to be from 3 to infinity. Okay, so that would be the answer if they wanted you to know what part of the graph is above the x-axis. Okay. All right, so okay, so we have each of these, and then the below is the two pieces. We've got the section from -5 to -3, and then from 0 to 3. Okay, so -5 to -3, and then we have it from 0 to 3. Okay, so 0 to 3. All right, so that's the places where the graph is going to be above and below the x-axis. So again, they do ask you that on these questions, but they won't have you do range at all. You're kind of doing that in a way, but not exactly. So above and below, we're just asking you to write the x values. So these are going to be interval notation when you do that. Okay, so that one now is complete. Okay, so let's move. So the last one we only had to do one test point, and that was enough to determine what the entire graph was with only one test point. Now sometimes we have more than one test point we have to use, such as this example here. We're actually going to have to do a few test points in order to determine what the shape of this is. All right, so first of all, we know that this is y equals x over x plus 2, x minus 2, nothing cancels. So we go on, set the top equal to 0. Not much to do there. We just get x equals 0, and that's it. If you put a 0 in for x, you're still going to get a 0 here. 0 over -4 is 0. So our only point that's on the graph that we found was 0, 0. So it goes through the origin. Now we want to find the VA. The VA, you're going to set the bottom equal to 0. So we already factored this, x plus 2, x minus 2 equals 0. So x equals -2 and x equals 2. Let's put those on here. Okay, vertical lines, we have -2 and -2 we have on here. So now we have that. Okay. Next thing we want to look for is the HA, the horizontal asymptote. All right, so horizontal asymptote, we look at this, the highest power on top is a 1, the highest power on the bottom is a 2. So this is a case of rule number 1. N is less than M. These are all the rules we talked about in the previous section. That's where I'm getting these from. So N is less than M. Okay, when that happens, automatically Y equals 0. So I know that the horizontal asymptote for this is Y equals 0 because we use rule number 1. Okay, so right along here, I'll just put a dotted line across this. So now we've got, the graph is all set up. Okay, so unfortunately, this graph does not give us enough information. It was not as nice as the previous one because now we're going back to determining, does the graph, is it going to be above the x-axis or below? We have to figure out which section that's going to be in. So we have to use test points for that. Also in the middle, with those 4 shapes, it could be a U shape, an upside down U shape. It could be a cube or a cube going the other direction. It could actually be any 4 of those shapes in the middle. So in this case, this is the case where we have to use the most test points. This one actually requires us to use 4 test points. Okay, so I want to do 4 test points here to determine what's going on. So for this, I'll do all these test points down here. So what I want to test is one point that is to the left of this. So I'm going to try -3, and then I'm going to try 1 on each side of the 0 here, and I'll try 1 on this side. So I'm going to first start off by using the endpoints. So I'm going to test x is equal to -3, and then I'm going to test x is equal to 3. That'll take care of the 2 end pieces, so that way I'll know what it looks like there. Then I'll have to test 2 of them in the middle, at -1 and 1. That'll tell me what's going on in the middle. Okay. The original graph is x over x squared minus 4. So I'm going to do y equals -3 over -3 squared minus 4. Okay, so that's going to give us here -3 over 5. So I get the point -3, -3 fifths. Okay, so -3, -3 fifths, we get there. So that's going to give us a point right there. Okay, that's going to tell me that the graph now is going to be below. So right here, now I know that section is going to follow this dotted line. It'll hit that point and then go down the other one. So now I know the graph is below. But I also want to test 3. So I'll do 3 over 3 squared minus 4. That's going to be +3 over 9 minus 4 is 5. So this is going to be the point 3 and +3 fifths. Okay, which means that I'm going to have a point right. So 3 and 3 fifths is about right here. So now that tells me the graph is going to be in this section like that. So I'll do that part. Okay, so now I need the part in the middle. Okay, so I need to test, I'm going to test -1 and a 1. That's going to tell me what kind of shape I have in the middle here. Okay, so let's test. I'm going to test x equals 1, and we're going to test a -1, and we'll test x equals 1. So -1 and 1. Okay, so you got that. Okay, so y equals -1 over -1 squared minus 4. That we get -1 on top, and then -3 on the bottom. So 1/3 we get because the negatives cancel out there. Okay, so the point that we're going to plot is -1 and +1/3. We'll plot that in a second. Let's get the next point done. So 1 squared minus 4. This is going to be -1/3. So we do 1 and -1/3 is the point we're plotting here. Okay, so now these points, we're going to plot those now on the graph. So -1 and 1/3. -1 and 1/3 will be about right here, and the other one was 1 and -1/3, which is there. So out of the 4 shapes that you could have, so again in the middle, you can either have a U shape, upside down U shape, a positive cube, or a negative cube. Those are the four shapes that we could have always in between the two vertical asymptotes. The way these points are set up here, the only one that fits is this last one, the one that looks like a negative cube. So we're going to follow this vertical. It's going to curve and hit these points here. Then it's going to go down and follow the other one like that. And that is now going to be your graph. So that's how you can find that by using test points. Okay, but again, you'll just be looking at in the homework, it'll just be a multiple choice thing, and you'll just select that. We are, however, now going to do the other part that it asks you to do. It asks you for what part of the graph is above and below the x-axis. So now let's do that. Okay, so what I'm going to do here is I'm going to write that up here. So that way I don't have to keep flipping up and down the screen for you. So I'm just going to put that up here instead. All right. So what I'll do next, I'm going to do f of x. So f of x above x-axis and f of x below x-axis. Okay, so we're going to go ahead and write each of those. All right, now let's start with above. Above is so here's the first piece between -2 and 0. Okay, so between -2 and 0, the graph is above the x-axis. And also between 2 and infinity, the graph is above the x-axis there. It's below the x-axis from -infinity to -2, -infinity to -2. And it's also below from 0 to 2. Okay, so you're finding the part of the graph below the x-axis and above the x-axis, and that's what we're doing for this one here. So in this case, we did have to do 4 test points in order to determine that. So that's going to be our answer on that one. All right, so we get all our information. It's always good to do these at the very end. Once you have the graph complete, then we have it done. Now, there is a way that, of course, you could do this algebraically, and that's using the section that we talked about on the last test. We did section 4 or 5, where you solve them algebraically to determine whether it's above or below. But then you'd have to do this is greater than 0 or less than 0. You'd have to set it up like that and go through the table method or number line method. But it's a lot easier just to actually use your graph as the answer. Of course, assuming your graph is correct, because of course, if your graph is not correct, that means you won't get these correct either. But again, it'll still be easier to do once you have a graph that's drawn. All right, let's go on to, so now this one looks very similar to the one we just did, except that now we actually have it flipped. Got the x squared minus 4 on top, and the x is going to be on the bottom over there. Okay, so this again factors into x plus 2, x minus 2 all over x we have down below. So now we're going to do x-intercepts at the top equal to 0. So x plus 2, x minus 2 equals 0. So we get x is equal to -2 and 2. So this time, these are not asymptotes. This time we have it, these are going to be actual points on the line. That's where it crosses the x-axis. For this next one, we want to do the y-intercept, put a 0 in for x, but when that happens, we get undefined. So there's no y-intercept. Okay, no y-intercept this time. Okay, that happens again whenever you get something undefined and you can't solve for it. Then we know there's no y-intercept. So it doesn't cross that. Now the reason why there's no y-intercept here is because the vertical asymptote, you're going to set the bottom equal to 0. So the reason why there is no y-intercept is because we actually have a vertical asymptote that runs through. So the y-axis itself is actually the asymptote this time. So that's the reason why we don't have an intercept, because the graph cannot cross that one. Okay. Now for the other one, for the HA, Highest power on top is a 2, and the highest power on the bottom is a 1. So in this case, what we have is I have a rule number 3 from the ones we talked about last time. N is greater than M. So this says that there is no y-intercept. However, but we do have an oblique. Okay, there's no y-intercept, but we do have an oblique or slant asymptote. Now, in order to find out what the slant actually is, we have to use division on this. Now, I did show in the notes with the long division, but again, this is one that we could actually do by synthetic division. We have to figure out what that is. So we're doing x squared. I can think of this as x squared plus 0x minus 4, all this divided by x plus 0. That's kind of what you can think of that as if you translate it into something where it has all the terms. So 0, you would put that into the box, and then we have a 0 placekeeper here because there's no x terms. We would do a 1, a 0, and a negative 4. And then you just drop this down. 1 drops down. 1 times 0 is 0. We're adding when we do synthetics. I'm doing synthetic division instead of long division. 0 times 0 is 0. We get a remainder of negative 4. If we were to write this out, okay, so the oblique asymptote, could ask for it, it would be y equals, this would turn into an x because originally I had x squared, and when you did synthetic, it dropped it down to just an x. The remainder, I mentioned this yesterday, you never include the remainder as part of your equation. So whatever the remainder is, ignore it and just do the quotient part. So I have x plus, technically I have x plus 0 is what that equation actually is. That's the equation of my oblique asymptote. I do want to put this on this graph here. Okay, so the equation of x would just be, the y-intercept would be 0, so it goes to the origin, and then the slope is 1, so we just go up 1 over 1. So for instance, if I'm here, it goes through 0, 0, it's going to go through 1, 1, 2, 2, 3, 3, and so forth. It'll do the same thing for the negatives. And so I have a line, let me do this as a dotted line, it's got to be a dotted line here, and I'll just continue this out there, and then this one. Okay, so I have a dotted line. That's my oblique asymptote. So now I have the graph is set up. So now I have to figure out where the graph is going to be. Now this time it does tell me that the graph crosses at these two places. So that's going to tell you where the graph actually exists. So because we know it crosses here, it's going to follow this dotted line. It's going to curve and hit this dot, and it's going to follow that one down. So the graph is going to be in that section right there. Then I also know it's going to be in the other section down below here. It's going to follow this dotted line. It's going to curve and hit that point, and then go out this way. So we didn't have to actually use any test points for this one because the graph gave us enough information to determine that. We only have one vertical asymptote here. So this is a little bit different than the ones that we've done before because the other ones had more than two vertical asymptotes. So now we only have just the one there. Okay, so that would be it there. That's your slant drawn in. All right, next. So this one, let's also do, okay, so let's do this here. F of x above x-axis, f of x below the x-axis. So f of x above the x-axis, it's above between -2 and 0. And it's also above this section right here from 2 to infinity. Okay, so this small section here is above, and this section also it's above. Okay. It's below the x-axis from -infinity to -4 or -2. And it's also below between 0 and 2. Okay, so it asks you for where it's above or below. Again, just read all that off the graph itself, and that gives you the answer there. All right. Okay, so now that we have that, that is complete. We're going to go on to the next one. This is actually the last one that we're doing in this section, and we'll move on to the exponents section. So this here is one where we have to factor, because if you look at the top and the bottom, it's definitely something we can factor. So let's go ahead and start with that and factor it. Then on the bottom, it's the easier one because that's the x plus 4, x minus 4 difference of squares. On the top, we've got a 3x and an x here. Okay, and then, so we'll do this by factoring by trial and error on this one. The 8, that can be a 2 and a 4. So I guess we'll try 2 and a 4 first. If not, we'll switch them to see if it works. But if we try it this way, we get 3x squared, we get a 12, and then we have a 2 here. So 12 and a 2 will give us a 10. That's what we're looking for. If we make this a minus and a plus, then we're going to get negative 12 and a positive 2 gives us negative 10. Then we have 2 times negative 4 is negative 8. So it works. Now notice that this one, we actually have something that we can cancel out this time. Okay. So that part that cancels out, that means that when we graph and we find all the information, we're actually just going to use this one here, 3x plus 4 and x over x plus 4. So it's one that we only have one vertical asymptote on this. So it's a little bit different than ones we did before, because now we got something that canceled out. So the part that cancels here, we do have to do something with that a little bit later. So we'll graph it first, then I'll show you what you have to do with that part that got canceled. But for everything else, for the intercepts and asymptotes, we're just going to use the reduced version. It's very important to use the reduced version when you answer these. X-intercepts at the top equal to 0. 3x plus 2 equals 0. And we're going to get negative 2/3. So negative 2/3 means we're about right there. That's the x-intercept. Okay. Put a 0 in first. Now all the other ones that we've done so far were zeros, but it's not always the case. It depends on what the equation is. So always plug in a 0 anyway to figure out what that is. So now this time we get 2/4, which is the same as a half. So this time we have a half that is right there. So that's our x-intercept and y-intercept. Vertical asymptote, you're going to set the bottom equal to 0, it says. X plus 4 equals 0, so x is equal to negative 4, which means we've got a vertical one right there. Next, we want to do the rules. All right, if you look at the reduced version, highest power on top is a 1, the highest power on the bottom is also a 1. So we have a case where we have rule number 2, highest power on top, n equals m. So rule number 2, n equals m. Then we want to use this formula, a of n over b of n. The coefficient in front of the x with the highest power is a 3 there, and there's a 1 down below here. So 3 over 1 we have for that. So this is equal to 3 over 1 or 3. So y equals 3 is the equation for your horizontal asymptote. That means you need to put that in here. It's going to go in, let's see, get in right here. Okay, so we got that. All right, so now we have to graph this one. And since there's only one vertical asymptote, the graph is either going to be below or above. Well, we know it's going to be below because we have intercepts here. That tells us the graph exists down in this section. So to follow this one, it's going to go through here like that. So again, how we know that is because if it was up here, the graph would have to cross the x-axis up here, but the only y-intercept we got was 1/2. So that tells us it has to be down below there. And that's what it is. Okay, so for that, so that's where it'll be in that case. Okay, so and then we're going to keep continuing this, and it's going to go all the way up, continue like that, follow that one. Now for the other one, since we didn't get any intercepts down below here, that means the graph has to be above. So it's probably going to be about the same distance away here. So somewhere out here, the graph will probably hit. So it'll be probably something that looks like this. So the graph will look something like that. The ones you'll have on the homework will be a little bit more centered for you so you can see. But this one here, that's what it would look like. It's got some symmetry. Now, originally, I told you about the 4 that canceled out here. Now, when that cancels out, if you set the part that cancels, if you set that equal to 0, x minus 4 equals 0, and I get x equals 4, this right here is going to be a hole. Okay, so this is called a hole. Okay, that means that at x equals 4 on my graph, I need to put an open circle. Okay, that's how I take care of the part that cancels. So if you have a part that, the only time you're going to have a hole is if something cancels. So there's a hole there because the graph doesn't exist at that point, because 4, if I put 4 in the original equation, that's going to cause division by 0. So because the 4 caused division by 0 in the original one, that cannot be included on my graph. So even though the whole graph does look like 3x plus 2 and x plus 4, it'll look exactly like that, we have to account for the open circle at that x value that caused division by 0. Okay, so there's no asymptote there, okay, because it canceled out, but we have an open circle that's there. So that's going to be the difference there. And so that's what your completed graph looks like. Now it's correct because we've got the open circle at the x value of 4. You'll just put an open circle on the graph at that point. Okay, so that is it now for this section. And so now the next thing is we're going to move on now to the 5.3 section is going to be next. And 5.3, so we already did, if you're wondering why we're not doing 5.1 and 5.2, we actually did those already. That was on the first test. So 5.1 and 5.2 was the f of g and g of f and the inverse functions. That was all in 5.1 and 5.2. So now we're going to jump back to chapter 5, and we'll basically just finish out chapter 5 for the rest of this course. We're also going to do a little bit from chapter 11 as well. But we have 5.3 exponential functions. We're starting with this here. Now, before we jump into any of these, I want to do a review of laws of exponents. So here's all the different laws of exponents that we have for each of these. I'm just going to go through, just explain each one. There are examples provided for all these. So these are all in your notes, so you can refer back to those. But I'll just talk about some main ones that we're using. I want to just refresh some of these properties for you that you're using in this section. So first of all, we've got if you're multiplying something with the same base, you want to add the exponents together. So a to the s plus a to the t is a to the s plus t. So we have these two here. So if you have 2 to the 5th and you're multiplying it by 2 to the 3rd, it's the same base. You're just going to add the exponents together, 5 plus 3. That's going to give you 2 to the power of 8. All right. Next, we're going to do, if you're dividing two things that have the same base, you want to subtract the exponents. So we have the top one minus the bottom one there. And as this example, you can see here, 2 to the 6th over 2 to the 3rd. Subtract the exponents, you get 2 to the 3rd, or you can turn it into 8. 2 to the 3rd is 2 times 2 times 2. A power raised to another power, you're going to multiply the exponents. That's the third rule. 2 to the 3rd times, and then all that's raised to the 5th power. You just multiply the exponents, and you get 2 to the 15th power. Anything raised to the power of if you take one raised to the power of anything, doesn't matter what it is, it's always 1. So 1 to the 34th power, that's going to be 1. Anything raised to the power of 0 is always 1. So 4 to the 0 is 1, and pi to the 0 is 1. We'll talk about that in later sections, where the 0 comes from. We'll come back to that in a later section. We'll explain that. And then we have a couple negative exponents down here. So if you have a to negative s, you can flip it over and put the s on the bottom. So 1 over a to the s there becomes positive. So anytime you move that across the division bar, you can change the sign of the exponent. Typically, the questions will ask you to write something with positive exponents. And so that's the reason why you want to use this rule here. So 4 to the negative 2, you want to evaluate that. That's 1 over 4 squared. And that's the same thing as 1 over 16. The last one is if you have a fraction. If you have a fraction raised to a negative number, you can flip the fraction and make the other number positive. Okay, so 2/3, if you flip that, it becomes 3/2. That gives you a positive on the outside. Then you can square the top and square the bottom, and you get 9/4 for that. Okay, so the first example we're going to come to here is we're approximating this by using a calculator. All right, now on your calculator, you should have a calculator in this class that has a exponent key that's on it. So the exponent key, it depends on what calculator that you actually have here, but it's going to be, you might have a y to the x button, you might have a caret key like this, you might have an x to the y, something like that. There's a whole bunch of different ways that, depending on what calculator you have, there's all different buttons because they're all different. So you might have one that has one of these 3 buttons that's on it. Okay, so what you want to do, most calculators, you would hit 5, and you would hit some kind of a button. I'll just use a caret key for example, but it could be any of these 3 buttons here. And then you put in a square root, and then you put in a 3, and then you put equals, and that's going to be your answer. Now, some calculators, if you have the TI-30 XA calculator, if you have TI-30 XA, that one's done a little bit differently. That one you'll hit 5. I believe that's a y to the x key. You know, put the 3 in first, and then the square root, and then equals. So that one's done a little bit different order. So if you've got that kind of calculator, yeah, so let me make that more clear here. So you put 5, hit the exponent button, the 3, the square root button, and then equals button on the end. And then that's going to give you the answer on that. So depending on what calculator you have, you want to be familiar with how your calculator works. Now, if you do have a graphing calculator, that's perfectly fine. You can use that certainly in class. And so, but yeah, so depending on which one you have to enter it a little bit different. So if you put that in, if you do that correctly, you're going to get, and you're rounding it to 3 places, so you should get 16.242 if you round it to 3 decimal places. So that's the answer you should get if you did it correctly. If you're not getting that, you want to go back and double check. And this makes sense because square root of 3 is about 1.5. So 5 to 1.5, that's about right. Makes sense for what you're doing there. Okay, now the E button. If you look at your calculator, most calculators have an LN button, and then right above it, you should see either an E caret key or maybe it's E to the X key you might have right there. So what you want to do on this is typically you're going to put in, you'll just put this E caret key first, and then you put in 1.6 and then equals. Again, if you have a TI-30 XA calculator, you want to actually enter the 1.6 in first, and then hit the shift button. You have to hit the shift button and then LN, and then equals for that. So on a regular calculator, though, you will have to hit the shift or second key because it is above the LN. So you want to hit a shift or whatever it is on your calculator, a shift or whatever key it is to get you that. And so that's how you do that one. Okay, so for this, if you do that e raised to the 1.6 and you're rounding this one to 2 decimal places, that's going to be 4.95. Okay, so 4.95 is the answer. So that's the answer for that one. 4.95 is the answer for this one here. Okay, so 2 different buttons on your calculator. So there will be some questions where it might ask you to do something like that. There's also the final exam, believe it or not, there actually is some calculator questions on there that has to do with the exponents. So you'll see that on there it's part of your, by the way, we have a review that's going to open up on Monday actually, for it's a bonus. And so I mentioned at the beginning of the semester that there is a review for the final exam that's done in my open math. And if you do that and complete it, then that's going to give you 3 points added to your final exam, which is actually 5%. And so because this is a departmental exam, it's actually kind of important to go through that review. So it is going to first become available on Monday. So you'll have like 2 weeks to do it. But I just want to have it come available a little bit earlier for you so you have plenty of time to work on it. And that's going to give you a really good idea of what's going to be on the final exam. The questions on there are very similar to the ones that are on the actual departmental final. So the reason why I let you do that is because some of the questions do look a little bit different in style than what we did in class. And so that's why, but it's the same material we already covered. So this just asks you a little bit differently. So I just want to make sure you're aware of the format of that. But, we'll talk about that more when it gets closer. Okay, so let's, we want to talk about next is we want to do this graph of 2 to the x. And it's a new graph we haven't seen yet. So whenever we have a new graph we haven't seen, we can always make a table and plot the values. Okay, so we've got 2 raised to -2, which is 1/4. So we have -2 and 1/4. So actually, I think I did it. Hold on, let me go back. I did that a little bit too fast for you. Let me show you what the reason why that comes from. -2, I'm going to put that on the bottom when it becomes a positive exponent, and then it becomes a 1/4. So sorry about that. I went a little bit too fast in that one, so I just want to explain where the rules, where I got that from. 2 to -1 works the same way. I can put that on the bottom to make it a positive exponent. It becomes positive, and so 1/2 to the 1 is 1/2. That's -1 and 1/2 right there. 2 to the 0, anything raised to the 0 power is 1. So 0, 1. 2 to the first power is just 2. So 1, 2. 2 squared is 2 times 2 or 4. So I get 2, 4. And now we can plot these. Now, of course, we can use technology to do this, but part of the reason why we have a table is just for us to get a little bit of practice with our exponent rules. So that's the whole reason why I'm doing this by hand. But of course, we have technology that we can use to graph this. But right there, I will draw this in, and this right here is y equals 2 to the x. Okay, so now that one is complete. Now the E, I did this one in the notes. I'm not going to cover this here. It's real similar to what this one is. It's a little bit steeper, so you can look at the notes for that one. So I'm going to skip over this. It's basically just using a calculator for all that. So I'm not going to show that one here because that's in your notes. Instead, though, the one I want to focus on is actually this one, because this is going to have a similar result of that first one that we graphed. So the one with the fraction, I'll focus on this one instead. So for this here, we're going to do 1/2 raised to the power of -2. So we're just putting that into that one. Okay, so we have a fraction that's raised to a negative power. What we can do with that is if we flip the fraction inside, that's going to make the outside number positive. So now this is going to give us a 4. So we get -2 and 4. Then we have 1/2 raised to the power -1. If we flip the fraction inside, makes the outside number positive. So we get a 2, so negative 1 and 2. 1/2 raised to the power of 0. Anything raised to the power of 0, doesn't matter what it is. Anything raised to the power of 0 is 1, so we have 0, 1. 1/2 raised to the power of 1 is just going to be 1/2. So 1 and 1/2. Then 1/2 to the power of 2, you're going to square the top number and square the bottom number. So we get 1/4. So 2 and 1/4. Now let's plot these points and see what we get. We have negative 2 and 4, negative 1 and 2, 0, 1, 1 and 1/2, 2 and 1/4. So we get a graph that's falling down, say falling down like this. And it follows this along here. What makes this one, the other one that we did before, when we did the 2 to the x graph, notice that it's exactly reversed. The other one we had went the other direction. So in fact, let me put both of these on the graph. I'll put both of these on there for you so you can see what that one was. So I'm going to do this with a dotted line. So this is y equals 2 to the x, and this is y equals 1/2 to the x. Now to show you the difference between these two, if I have 1/2 to the x, now one thing I can do with this is I can write it as y equals 2 to the negative 1 raised to the power of x. I can change the 1/2. There's a 1 down here. If I move it over the division bar, it becomes negative like that. And so then I have y equals 2 to the negative x. Okay, so now I have this. All right. So 2 to the negative x here, if I look at that compared to 2 to the x, notice the difference. I have a negative and I have a positive here. That's a transformation. So if I put a negative on top there, then that's going to be, I have a negative when we have a positive, that flips the graph over the vertical axis right there. So that's what happens. We flip it over. Okay, so type of transformation. So these graphs are very similar in style. Now, when we get to graphing these, we are going to do some graphic transformations in this section. We don't need to worry about making tables because, again, transformations allows us to not have to do that. So for something like this, okay, the next thing we're getting to here, when I graph it with transformations, it asks you for domain and range, and the horizontal asymptote it asks you for as well. By the way, both of these graphs that we just did up here, both of them would actually have horizontal asymptotes of, so the HA on this graph would be y equals 0. Okay, it's y equals 0, but notice that there is not a vertical asymptote. Although it may look like it, this actually continues to rise forever, so there are no vertical asymptotes on these kind of graphs. Okay, just a horizontal asymptote of y equals 0. That's what you have on that. Okay, so when we take a look at this graph, this graph is for y equals 2 to the x. So that's the one we're looking at. So y equals 2 to the x. We have a couple key points that I'm going to point out here. We have 0, 1, and we have this one, 1, 2. Okay, these are the key points that we're going to use when we graph these with transformations. So if I have these two key points, then we know how to move them around and everything else on that. So for this one that we have 2 to the x minus 4. What we want to do is take the entire graph and shift it down 4 units. What that's going to tell us is that the number on the end is where the horizontal asymptote is. So my horizontal asymptote is going to be at whatever this last number is here, minus 4, because originally the horizontal asymptote was at 0, but then it gets shifted down 4 units. So now it goes down below like that. So it gets pushed down. But these points, these two key points, they also move exactly 4 units down. So if I have 0, 1, and I go 1, 2, 3, 4, it's going to now be at 0, negative 3. The other one is at 1, 2. If I shift it straight down here, 1, 2, 3, 4. It's going to be at 1, negative 2. This is going to be right here. Now, if I also wanted to do a third point, I certainly could. The third point would be 2, 4. So I could, that's another point that would be on there. So if I wanted to shift that down 4, that would put it right on the x-axis like that. So then I would know where it crosses the x-axis, but in this case, that graph, that's what it's going to look like. All it does is take the original graph and shift it down 4 units. Let's do the domain and range. Now for the domain on these exponent problems, you're just going to have negative infinity to positive infinity. The graph goes to the left, the graph keeps going up, it's going to keep getting larger and larger x values. So it uses up all the x values there. So therefore, the domain is all reals, negative infinity to positive infinity. Now the range it has to do with your horizontal asymptote. The smallest value is -4. And that's going to go all the way up to infinity. Now notice that -4 is not included because that is an asymptote. So the graph never actually reaches that dotted line. So that's why I got to put -4. That's the lowest value that I have there. Okay, so now that answers all the questions on that one. So let's move on to the next one. So now we have a y equals -2 the x graph. Again, here is my y equals 2 the x graph. I've got the 0, 1. I've got 1, 2. And if you want this third one, we can use that as well. 2, 4. These are all the special key points we have on this graph. The negative, what the negative does is if you have a negative on the x part, we actually did that up here. So for these graphs up here, notice I had a negative in the x position. What that does to the original one is it flips it over the y-axis. Okay, so it flips it over the vertical axis is what it does. But this time we have a negative that's in front of the exponent or in front of the base. We have it out front. A negative out front is going to flip the graph over the x-axis. So instead of all these being at 0, all these y values I have on my key points, they're all going to turn negative. So I'm going to have 0, -1. I'm going to have 1, -2. And I'm going to have 2, -4. There's a 2, -4 I have there. Now nothing changes with the horizontal asymptote. It's still going to be at 0, but now the graph is going to go down like this. Okay, so that would be the graph of what they're looking for, -2 the x graph. Okay, so domain is going to be from negative infinity to positive infinity. Again, it doesn't change. Horizontal asymptote didn't change from the original. That's still going to be y equals 0. But the range is affected. That's going to be from negative infinity all the way up to 0. But 0 has a parenthesis on it because, again, it's never going to reach the actual y value where the horizontal asymptote is. Now, before we go further, what I want to do is show you what a question like this looks like in my open math. So I'm going to switch over and show you how you want to graph these in my open math. So let's take a look at this question right here. That's 2 the x minus 1. So it's very similar to a previous one we did. The first example we did was 2 the x minus 4, but now we have a -1. Let me show you how you're going to use this tool that's here. Notice that there is one tool, so we'll click on that. And it's asking you for, there's 2 points, and it's also got a green dotted line on there for the button. The thing you're going to do first is you want to click on the y value where there's a y, where the horizontal asymptote is. Now, because it's a -1, we know that the dotted line has to go through -1. So we're going to click on that first. Okay. Now we need to click on 2 other points that are on the graph. So this is where you're going to click on 2 of your key points. Now, normally I would have a graph at 0, 1, but if we shift it down 1, that means it's going to go through the origin. So I'm going to click on that. And then as you see here, I can click on another point. The next one, it'll go through. I was at 1, 2. So now I'll be at 1, 1. and I can lock in my answer right there. And that's how you use the graphing tool on this one. So there's three clicks you have to do. One click is on the dotted line that you use to indicate where the horizontal asymptote is. You click on that, and you got to click on two other key points. So that's actually why I'm showing you these problems with key points, because with that, that's going to allow you to use the graphing tool correctly to lock in your two values. And of course, our domain, negative infinity to positive infinity, we've got the range would be from -1 is the lowest point in the graph, so it goes -1 all the way up to infinity on that one. And then it also asks you to indicate what the horizontal asymptote is, and you just click on the first blank and just type in y equals -1 right there, because that's what you clicked on. So it does something, it asks you for that as well. And the y-intercept, you can read that off the graph. It's at 0, 0 in this case. They don't always ask you that for that one, but this one does. And so that's the kind of question what it'll look like when you do these in my open math. So let's go ahead and flip back now to the notes. Okay, so we'll go back to that. All right, so yeah, I just want to make sure we kind of cover how you use the tool in there, because that's all the questions in there have you use that kind of tools. There's a lot of graphing questions where you have to use that same graphing tool. So let's move on to the next one. Okay, so now this is a little bit different because we have a different base graph this time. We have a 3 here. So this graph is going to be the y equals 3 of the x graph. We're just going to look at two key points here, 0, 1. But then the next one that we have is 1, 3. Okay, so these are the two special key points that you'll need when you do this. Again, I'm showing you key points because after you shift it, you'll need these two key points in order to use the graphing tool in MyOpenMath. Okay, so now that we have that, we're going to look at what this is doing. Now we have two different things going on here. First of all, we've got a -2, which means that that horizontal asymptote that was normally at 0 is now going to be at -2. So we just go ahead and put that in there, y equals -2 for the horizontal asymptote. So that's always going to be the case. Whatever number is on the end here, that's automatically going to become your horizontal asymptote. And we can automatically put domain is negative infinity to positive infinity. All these ones, it doesn't matter what it is. If it's in the exponential form like that, it's always going to be negative infinity to positive infinity. So that's always the case. Okay. And we have the y equals -2, so we have that. Okay, so we have to do some shifting on this. Now let's take a look at what's going on here. This part right there means we're going to shift 2 places to the left. Okay, it's always the opposite sign of what you see here. So instead of moving it in the positive direction, we want to move it in the negative direction, so it's moving to the left. So what's going to happen is these points that I have here, we have to do two things to them. We have to move it 2 places to the left and down 2 places, to the left and down 2. So if I do that for each one, to the left and down 2, this one here, it's going to move to -2, -1. So -2, -1, I'll make a dot right there. Okay. All right. Next, 1, 3 is going to move 2 places to the left and down 2. 2 places to the left and down 2. That's going to put me at -1, -1. Okay. So -1, -1, I'm sorry, -1, +1, I should say. That's going to be, it's right here. So -1 and +1 right there. Okay. And then I just draw in the graph like this. And that's going to be it. Okay, for that one. If I wanted to find out exactly where this graph crossed the y-axis, I could put a 0 in to here. If I put a 0 in so if I want to find the y-intercept, for instance, just for a little bit more accuracy, I certainly could. The y-intercept, x equals 0. So 3 equals 3 to the 0 plus 2 minus 2. That's going to give us 9 minus 2 or 7. So I know it's going to go through 7. Here's 1, 2, 3, 4, 5, 6. So I might want to make this a little bit more accurate by having it go through the correct y-intercept. Again, the graphing tool, the 2 points you have here will be close enough. But again, if you want to go ahead and do the y-intercept there, that's perfectly fine. 1, 2, 3, 4, 5, 6, 7. So go through right here. So I should send a cross right there instead. And that would be your graph. The range we need to do yet. So range is from -2 to infinity. Like that, -2 again with a parenthesis on it, and it goes all the way up to infinity. Okay, so that's that one is complete. All right. Okay, so this one here, I'll do one of these fraction ones, and we'll do the other one next time, but we'll do one of them here. What we have to do with this, okay, is we have to do a little bit. If you have a fraction in it, you want to do a little bit of work with it first. So I'm going to do a little algebra. So I have y equals. What I'm going to do first is change this to 3 to -1, like that. And so that way, the one that was down here, I bring it up over the division bar, it becomes negative. And then I can do one more thing with that. I can put a negative out front and do this. Okay, so now I have a 3 to the negative x minus 3 plus 1. I have all that. Now the base graph I have here is still going to be the 3 to the x graph because that's the base that I have with this one. So the same key points I had before, 0, 1, and I have 1, 3. Now, one graph that I want to look at, though, is because there's a negative up here in the top, that's going to be a flip over the y-axis. So this dotted line I'm putting in right here, this would be the graph of y equals 3 to the negative x. And they have these key points here. This is the graph I'm actually going to shift. So I want to take the graph of 3 to the negative x, and right here, 3 to the right. Okay, so the -3, we're moving it opposite signs. Instead of in the negative direction, we move it in the positive direction to the right. And then this says up 1. So we're going to take the graph of 3 to negative x. We're going to move those key points on that negative graph, this dotted line graph. We're going to move that 3 places to the right and up 1. So this dot, let's start with the 0, 1. We'll move it 3 places to the right and up 1. That means it's going to be at 3, 2. By the way, we can also put in the +1 is our horizontal asymptote. Was at 0, but the graph gets moved up by 1, so it moves up the horizontal asymptote as well. Okay, so we have a dotted line there. We have this point. This dot right here, that's going to move 3 places to the right and up 1. Okay, so 3 places to the right, 1, 2, 3. Up 1 means we're going to be at 2, 4. So 2, 4 is here. All right, so now these are the 2 points that the graph is going to go through. If we're doing this in my open math, we click on the y value of 1, and then just click on these 2 dots, and that would create the graph just like this. Okay, so that's what that one would look like. So again, we're starting with the flipped graph. The flipped graph is the one that we're moving. So we're starting with the 3 to negative x graph, and then we're shifting it and moving it into position. So we have 3 to negative x graph we're doing first, and then we're moving it 3 to the right and up 1. Now let's answer these questions based on that. It's going to ask for the, okay, so I'll just write them all here since we can just use the graph. So the domain is going to be negative infinity to positive infinity. Okay, if it asks for the range is going to be from 1 to infinity. Okay, and then the HA, horizontal asymptote, is going to be the equation of y equals 1. That's the equation for that. Did I do those on the previous one? Yeah, I did that. I did that on the other one. So yeah, so it asks you for these 3 things on these kind of questions with that. Sometimes it asks you for y-intercept, sometimes it doesn't. This depends on what graph that you actually have. Again, if I want to find the y-intercept, I just put a 0 in for x on this case. And so I would just put in I put a 0 in there, that'd be 3 cubed it would be plus 1, so it would be all the way up at 28, which is way off the graph here, but I could put that down if it asks for it. All right. So this one, we're almost done with this section. We do have one more. We have one more problem to do, or a couple, one more graphing problem, and we'll kind of get into the rest of it. So I'm going to go ahead and stop at this point, and we'll continue with this for tomorrow. And so again, hopefully the background noise wasn't too distracting for you. So we'll go ahead and end now. So anybody have any questions before we end this meeting? All right, so the only person that has a question is my dog barking. So I guess that's it for today. I'll go ahead and stop this, and then we'll continue tomorrow. Email me if you have any questions, as always.